So in this part of periodic classification, we will be taking certain topics such as nomenclature of inorganic elements, electronic configuration and periodic table relationship, then block elements and individual conceptual description of various blocks. Let's go by one, and first is nomenclature. Nomenclature of elements. Now it has three questions in a mind of a student. First, requirement. Second, how. And then third is applicable. First was how, second is requirement, and third is application. So let's take one by one. First is how we are going to name an element. Prior to start with this, we must know what is the limitation of naming of particular element. It should be more than 100 or 100. या तो ये 100 हो या तो 100 से ज्यादा हो. Next, it should be at least less than 1000. Now why? Because if it is coming in a 4 numbers, we have been given in the IUPAC system that first is taken as the name, second is taken as this name, and then third is added by IUM. For example, if we have 100, it is nillion. But nillion. But imagine if it is 4, then what we will get? Nillion. So this is the limitation of system. Now why it is left? Because initially when it was thought that we have to name undiscovered element which is going to be discovered, we have a concept that element cannot be more than 173. एलिमेंट 173 के बाद हो ही नहीं पाएगा क्योंकि इतना ज्यादा अनस्टेबल हो जाएगा कि ये बन ही नहीं सकता. बट सूनर और लेटर वी हैव फाउंड दैट द एलिमेंट्स आर नाउ अप टू 220. सो दिस हैज बिकेम अ लिमिटेशन. अदरवाइज, बिकॉज इफ एन एलिमेंट कम्स ऑफ 1001 or 1000, then how we are going to name? It is still 10,000, nil. So it is something which seems to be awkward, but still it is not given, so we are not discussing it. But it is just very correct for the elements up to 999. We can give a proper naming to the 999 element. That means 999 elements if they are discovered. So what are the basic requirements now? Requirements are, we must know what we should write when 0 is there. 0 is there, nil. 1 is there, un. 2 is there, bar. 3 is there, tri. 4 is there, quad. 5 is there, pen. 6 is there, hex. 7 is there, sept, not hept, sept. In that IUPAC, organic IUPAC, we use hept, and here we use sept. Then oct, n. Not known. Now again here, variation is there, n. E-N-N. Deck or E-N. Deck is not required because 1 and 0 is there. So let's have some example of this. 123. 123. So the name will be Unbitrium. Now why we are writing UIUM? Why?
Creative finishing.
No, because these are metals. For example, sodium, potassium, rubidium, cesium, francium. It is a naming of the element. When elements are named, there should be a
कोई भी element
metal is here.
metal
Metal we are having. So metal are named as them. All cationic elements. Because when you go for the details of this element, they never exist as an atom. ये एटम के रूप में एग्जिस्ट ही नहीं करते.
CHS इसलिए C होता है.
आयरन कभी एक एटम के रूप में एग्जिस्ट करेगा नहीं, वो एलिमेंट के रूप में एग्जिस्ट करेगा. और जहां पे एलिमेंट होगा वहां पर एटम नहीं होगा उसका. Because we have studied in our past that atoms are the building block. No, they're not building block. Now why not building block? Because if we take an iron rod is pure iron, and we will find that it contains positively charged cation and freely moving
electrons.
There is no atom in that. Any metal you take, any metal, it does not contain atom. And if you go for the periodic table, long form periodic table or modern periodic table, except 14-15 elements, all are pure metal. So if they are pure metal and metal does not have atom in the formation, so how we can say metals are atoms are the building block? So atoms are no more building block of element.
They call limitation.
Now we come to, so they are written as IUM. And if they are negatively formed element, then they must be given some other name. For example, hydrogen as hydride, sulfur as sulfide, sulfide, sulfate, sulfite. Ite is for negative ions, and IUM for positive ions. So all metals form positive ion. In fact, they are present in the form of positive ion inside the atom. So inside the element. So we are writing them as a IUM. Sodium, potassium, calcium, strontium, barium. If we go for iron also, iron, ferrum. So UM is the property where we must see, and if it is written, then we come to helium. Now why? Helium is a metal, no. But when it was discovered, it was discovered in the form of positive ions, that is He plus 2. So people thought that it's a metal, but it was not a metal. But naming as it was done because of the formation of ions. And this was the reason why hydrogen was named as protium, deuterium and tritium. Why? Because they also form the positive ions. And if we go for chlorine, chlorine has two types of ions. Chloronium, Cl plus, bromonium, iodonium, hydronium, H3O plus, OH, hydroxide. So if minus is there, I A, and if positive is there, IUM. So we can name the element now this. Then we have a second part, that is electronic configuration periodic table. Modern periodic table. Modern periodic table is based upon electronic configuration. Modern periodic table is based upon electronic configuration, and therefore we can have the properties. So atomic number based upon atomic number and electronic configuration. So they are written in the various forms, and on the occurrence of the element in their last subshell, they are divided into blocks. If the last element, remember, last element, not outermost. Last element. लास्ट एलिमेंट जिस पीरियड जिस ग्रुप में जिस ब्लॉक सबशेल में जाएगा उसी पर बेस्ड ये नेमिंग होगा. लास्ट इलेक्ट्रॉन जिस सबशेल में जाएगा. So sometimes outermost electron goes to S And that was the reason why this copper and sodium or potassium, they were kept in together in the first group by Mendeleev. Because he didn't know that where the electrons are going. First the electron is going to 4s and then at the last it goes to 3d. So as it is going in D, it is presenting D subshell or D block. So if the last electron goes to S subshell, S block. Last electron goes to P, P block. Last electron goes to D, D block. Last electron goes to F, F block. Last electron goes to G, it will be G block, commonly known as super heavy elements. Then we come to S block elements. S block elements have two vertical columns, commonly known as alkali metal and alkaline earth metal.
Yes.
P block element, commonly known as P block typical elements, because they possess all the three types of element: metal, non-metal, and metal ion. D block is known as transition metal because it is present in between S and P block. Remember, the name transition is given only because of they are present in between S and P block. Many times we discuss or we get confused that these have transition property, or does not have transition property, or do not form complexes. But all present in between S and P. If you go for NCERT, again the page number 2 or first of transition elements, you will find that the name transition is given only because of they are found in between S and P block.
They show both the characteristics.
They are present in between S and P and nowhere else and nothing else. Then F block, inner transition element. Now this is given because these elements are present within the group, within the period. For example, there are two F blocks, lanthanide and actinide. Now these two acquire the same position of the lanthanide of the actinide. जिस पोजीशन पर पीरियोडिक टेबल में लैंथेनाइड है, ग्रुप और पीरियड सेम दे आर, उसी जगह मिलेंगे। लैंथेनाइड के साथ ही 14 के 14 एलिमेंट वहीं पड़े हुए हैं, सेम पोजीशन, एंड दे आर इन द दिस please 5th and 6th D group, or we can say 6th and 7th period. Lanthanides are present in 6th period and actinides are present in 7th period. And they have the, as they are present within the period, within the group, they are found known as inner transition elements. Then we come to various properties and why the names are given so far and general trend in the next part.